When we analyze the Japanese Navy's anti-aircraft operations during the Second World War, scrutiny is often placed on the weapons themselves, and less thought is placed into the fire control systems, even though those are arguably more important than the weapons. Regardless of how good a weapon's quality is, its effect would be neutralized without any form of control. The Japanese began to understand this from the development of their very first high-angle gun, which was the .40 caliber third-year Type 8cm high-angle gun, which began development in 1914 and began production in 1916. This weapon would never receive a fire control director, and the shortcomings were obvious, as using eyesight and pure guesswork to hit a moving target while you are also on a moving target was near impossible. And so, when the succeeding weapon was developed in 1918, that being the .45 caliber 10th year Type 12cm high-angle gun, which began production in 1923, the Japanese were dedicated to the concept of some form of control. The Naval General Staff had set forth very basic requirements. The system had to be capable of discovering a target, measuring the distance of the target, and then calculating where the target would be by the time a fired shell reached its position. The Japanese would first conduct tests with controlled fire in 1926 and then again in 1929 using the Type 89 high-angle firing board, which was a very basic system and was unsatisfactory. Based on the testing that had begun in 1926, the Navy Technical Department began designing what would eventually be the production fire control system, with the design being completed in 1929. This would go on to be the Type 91. The Japan Optical Company was tasked with the production of the Type 91. The first unit was delivered to the Navy in 1932, and it was installed aboard the battleship Yamashiro, which at that time was a training ship at a gunnery school. Right off the start, issues began to appear, and as more and more Type 91s were delivered, more and more issues were discovered, and most were related to the same complications, and that was the fact that the Type 91 was two separate units. The first unit consisted of the director and computer, which were located within a rotating cupola. The second unit consisted purely of the 4.5-meter rangefinder, which was in its own separate rotating cupola. The rotation of the two cupolas were in no way connected, and this meant that the director and the rangefinder could be looking at separate targets, and neither crew would be aware of that. The rangefinder arm was also biaxial. This meant it had a complete lack of leveling and cross-leveling, which meant there was a significant margin of error between it and the director. In 1933, while testing the Type 91 using the Type 89 12.7cm high-angle gun, it was found that the probability of hitting was 0.4%, which was almost as bad as not having a fire control director at all. As a result of the problems encountered with the Type 91, it was obvious a new unit was needed, and as soon as possible, and so, in 1934, the development of its successor began. Production would begin in 1937 in Nippon Kaigaku Kogyo Kaisha and their subsidiary plants, and production would be at a steady pace of 5 to 10 units per month. This unit would go on to be known as the Type 94 high-angle director, which was a massive improvement over the Type 91. The rangefinder and director were now combined within a single rotating cupola, which guaranteed they were both always observing the same target. The computer was separated and placed below decks within the ship's citadel, which meant that one hit would not be able to disable both the director and the computer. The rangefinder would use the same base length of 4.5 meters, but it had better rotational and elevation characteristics, which improved its quality and speed of target acquisition. Most of the improvements certainly took place with the production of the computer, as compared to the Type 91 computer, which often had errors due to mechanical interference. The production of the Type 94 had better precision of the three-dimensional cams and gear cutting, which would result in more reliable calculations, as mechanical failure would not be as common. And rather than being a two-step calculation, it was a single-step calculation, which was for greater simplicity. The computer would also receive what the Japanese Navy called the coordinate converter, but the United States Navy would go on to refer to as the spherical deck tilt corrector, which indicated to the computer the deck tilt of the ship that the computer was located on. The computer would receive this information in triaxial data, and so, before it was transmitted to the guns, which only had biaxial characteristics, being training and elevation, the computer had to correct the triaxial data into biaxial data so that it could actually be input to the guns. Beginning in 1938, the aircraft carriers Soru and Hiru would begin testing the Type 94 fire control system with the 40 caliber Type 89 12.7 cm high-angle guns, and the results were a massive improvement as the hitting rate was now 6.58%. The chance of hitting the target over the Type 91 increased by 16.5 times. After the war, when the United States Navy was examining the Type 94, they considered it an overall excellent fire control system and compared it directly to the Mark 37, which they found were very similar. The United States Navy also noted that while examining the Type 94s, that they were well-maintained and very clean units compared to the Type 91, for example. While the cleanliness of the Type 94 would go to show the great faith that the Japanese must have placed into the Type 94 throughout the war, and they certainly did, it did not mean that the Navy neglected its issues and were not looking for an alternative unit, as in June of 1942, Japan lost the Battle of Midway with 5 capital ships being sunk, 4 aircraft carriers, and a heavy cruiser, all as a result of dive bombers, which was the primary target of both the Type 94 Director and the Type 89 gun. While the Japanese had to continue to use the Type 94 until a replacement was ready, they would have to improve it. For example, the Type 94 Modification 1 would see the addition of a pendulous gyro. They would also attempt to improve the computer to where it could receive data from radar units, even though radar was never actually connected to the director or computer. As a result of its shortcomings, the Naval General Staff requested that the Kure Naval Arsenal begin the development of a replacement, and this began in 1943 with what became known as the Type 3. Unfortunately, not much is known about the Type 3, as by the time the war ended, the prototype was only partially completed and the unit never entered production. This means we're not exactly sure of the build of the Type 3. No drawing or schematic has ever been discovered of the full unit. What we do know about the Type 3 is that its development was an attempt to increase the solution time of calculations for a target, which would subsequently increase the rate of fire of the weaponry and increase the chances of hitting a target. The way the Type 3 would do this is described by the United States Navy. First, complete blind fire using radar data. Second, control officer has scooter control for slewing to train the director on any target which he selects. Third, an estimated target course and speed can be set as to get approximate deflections without having to wait for a solution time. 4. Simple conversion to other ballistics. 5. No ballistic 3-dimensional cams, hand follow-ups instead. And 6th, highest possible accuracy with wind corrections to future range and vertical components of deflection. Unfortunately, due to never seeing service, we will never know the quality improvements of the Type 3 over the Type 94, but based on the improvements the Type 94 introduced over the Type 91, we could expect that there would be significant differences that would be noticeable. With that having been said, I have nothing more I wish to add on to this topic for today. So, if you have learned something new in this video, why not leave a like and a comment down below, and have a wonderful day.